Hey there, and welcome. We're going to talk about something that's, well, pretty fundamental to our digital lives: how our devices actually organize information. We're going to pull back the curtain on the simple building blocks that power everything from your music playlist to your grocery list. I mean, have you ever really thought about it? When you type in milk, eggs, and bread, how does your phone know what to do with that? How does it store that list, keep it all in order, and then show it back to you later? The answer is in just a few simple building blocks, and we're going to start with the most basic ones. So to understand how a computer builds something like a list, we first have to look at the simplest little pieces it can work with. It's just like a recipe, right? Before you can cook anything, you need to know your basic ingredients. You see, a computer can't just look at the number 5 and magically know it's a number, or look at the word hello and know it's text. We actually have to tell it what's what. In programming, these different kinds of information are called data types, and we're going to check out the 3 most common ones. First up, we've got numeric data. This is pretty straightforward. It's just numbers. It could be a simple whole number, like 2, or what's called a floating point value with a decimal, like 23.42. The computer sees these and knows, okay, I can do math with this stuff. Next up, strings. A string is basically just text, a bunch of characters strung together. The key thing here, the thing to really notice, is the quotation marks. There is signal to the computer that says, hey, treat everything in here as text. And that's why even something that looks like a number, like 2345.432, is a string. Because it's in quotes, the computer won't try to do math with it. It just sees it as a sequence of characters. And our third basic ingredient is a Boolean. This one is the simplest of all. It can only ever have one of 2 values, true or false. That's it. You can think of it like a light switch. It's either on or off. Booleans are super useful for asking simple yes or no questions in a program. Okay, so we've got our ingredients: numbers, strings, and Booleans. But just like in a kitchen, you can't just leave your ingredients lying around on the counter, right? You need a way to store them and label them so you can find them when you need them. In the world of programming, these containers are called variables. A variable is really just a name that we connect to a piece of data. You can totally think of it like a labeled jar. You put your data inside, and you slap a name on the jar so you can easily grab what you need later. For example, we could create a variable called visitor_name and just tell it to hold the string Chris Bates. And now whenever our program needs that name, we can just use the variable visitor_name instead of typing the whole thing out again. Super handy. Now, this is great for single items, one jar for one name. But what about our shopping list? We don't want to have to create a new variable for every single item. Item 1, item 2, item 3. That would get really messy really fast. We need a container that can hold a whole list of items all at once. And the solution to this problem is one of the most useful tools in all of programming. To organize lists of information, we use something called an array. So let's imagine we have this slightly strange list of items. We've got some text, a number, and some more text. One of the really powerful things about arrays in a lot of languages is that they can hold all these different data types together in the same list. So, what is an array, really? Well, an array is just an ordered list of items, all stored together under a single variable name. So instead of having a dozen separate jars, it's kind of like having one big container with neat labeled slots inside. And here's how we turn that list into actual code. We create a single variable, items, and we assign it our list of values. See how each item is separated by a comma? And the whole thing is wrapped in square brackets. Now all 4 of those items are neatly organized under just one name. So, how do we get a single item out of the container? We don't use the item's value like cat. Instead, we use its position in the list. That position is called its index. And this is where the ordered part of the definition becomes so important. Now, here's probably the single most important rule to remember about arrays. And it's something that trips up pretty much everyone when they're first starting out. In programming, we don't start counting from 1. We always start counting from 0. So the crucial thing is this. The first item in our list, dog, is at index 0. The second item, cat, is at index 1, and so on. To get that first item, we use the name of our array, followed by the index in square brackets, just like this, items 0. And that gives us back the string dog. Okay, so we've talked about data types, variables, and arrays, and These might seem like really abstract programming concepts, but they are the quiet foundation for so much of our digital world. I mean, really think about it. Every time you add a song to a playlist, you're adding an item to an array. When you scroll through the contacts on your phone, you're just navigating an array of names and numbers. And that shopping list we started with, at its heart, it's just a simple array of strings. So it all comes down to this really simple process. You start with your basic ingredients, the type of data you have. You put each piece of data into a labeled jar, a variable. And when you have a whole list of related items, you organize them on a recipe card, which is our array. The key takeaway here is that once you understand these core ideas, you've already taken a huge step toward understanding how software thinks. It isn't magic, it's just the art of organizing simple pieces of information in some really clever ways. Ultimately, understanding the structure of information, that's the first step to creating anything, whether it's a simple shopping list or a really complex application. What looks complicated on the surface is almost always built from these simple, elegant building blocks we just explored. What will you see differently now?